Hello and good morning, beautiful people. Let's solve the optimal solution for the Pascal's triangle lead code questions. So, first of all, what we are going to recall is every row of Pascal starts with 1. So, instead of recalculating factorials each time, we can get the next element by taking the current one and doing this. Okay, I'll write the formula. Current into row minus column divided by column plus 1. Okay, by doing this. So multiply before dividing. So we do exact integer arithmetic. What we do here, we build each row left to right and push the current value. Okay, after pushing, what we do update it. So after updating, we will be repeating this until we have built num rows. Okay, until we have built num rows, we will keep on repeating. So this does work over the time complexity of order of n square, which I'll be explaining you in further video, because we will notice that the triangle has about n square by 2 numbers of triangles. Now let's revise the code. Okay, we'll write the code. So skip this part. We'll start from class solution. I think I should change the pen because this is not clearly visible. Okay, I'll take the blue one. This is little dark. So class solution public, this is already given, so this line is also given in the lead code, but sometimes you'll need to write from scratch, so you should have a practice. So here we have a generate function, okay, and the int num rows is the input, as we already know, right? So we will again take vector int result as a notebook to store our result value. Okay, now we will take a loop for int row equals to 0, row less than num rows, row plus, sorry, it's small, row plus plus. Okay, now why we took this for loop? Because why row over this, we have, suppose we so this loop goes from 0 to num rows, okay, and it keeps on increasing until it reaches the num rows. Each iteration builds one full row of Pascal's triangle. So we took this loop. Again, what we are going to take, we will take vector int current row. Okay, we'll take this. Why? Because we were taking the reference of a notebook teacher, something like that, to make you clear with examples. So I'll take a reference of that. So what we are going to do here is open a fresh space current row to write the entries of the current row in this. Okay, now we know that what we know is our value is 1, because we have seen in the example the s element was always 1, right? So we'll store the value as 1 because the first element will always be 1. Okay, now what this will do is start this row with value 1. Mathematically, the first row, this row will be 1 only. Okay, and why we have used long? Because to safely hold the intermediate multiplication results. That's why we use long. Okay, now again we will take the next loop for int column equals to 0, column less than equals to row, and we will increase the column plus until we reach the row. We will be increasing the column. Why? Because for this row we need row plus 1 entries. Okay, now we will push back the value into the current row. Okay, so what we will write? Current row dot push back int val. Why we wrote this? What this does, write the current value into the row. So we cast to int because binomial coefficient here fits into the int for typical constants that we have been provided. Okay, so but we are keeping the value as long here. Okay, long while computing to avoid the overflow of intermediate multiplication, as I have already told you above. So as I have mentioned, the formula that I have used here, this formula we have used for the optimal solution. So now next we will write val equals to val star row minus column by column plus 1. Okay, what this does, this single line updates value to the next binomial coefficient in the same row. So what is important here? Multiply first the value into row minus column, then divide by this. So this division is exactly because of the algebra we are using here. So the integer division is really safe. Now we will end the inner loop. Okay, then what we will do? Again we will push back the current row. Result dot push back the current row. Okay, we will push back the current row. Done. What this does, the notebook result is completed now. So in this loop, now we will return what? We are going to return result only because we have taken above the result as the small r. So this returns the full notebook, full triangle to the caller, the generate function. Now we will end this completely. And if we see the example, if you want to see the example,